What is your major here at MIT?
Aero Astro.
Do you think you can answer 5 questions every aero astro engineer should know?
Sure. I do CS though, so I'll try.
Okay, do you want to answer questions CS or aero astro?
Can you do like 50-50 mix?
Yeah. What year are you?
I'm a fifth year PhD.
Okay, so I'm going to ask you 5 questions. Each one will get harder if you get it right. Okay, and I'm going to give you some hard ones because you're PhD. Okay, number 1, starting off easy. How do guidance, navigation, and control systems handle state estimation under uncertainty in deep space missions?
Gyroscope.
1 for 1. What are computational and algorithmic challenges of real-time autonomous hazard detection and avoidance during planetary landing?
The payloads are pretty high during planetary landing, and you might need to do like a long, big computation that might take like a long time. So like for high speeds, it would like not work.
What is the relationship between the polynomial hierarchy and circuit complexity?
So you can represent circuit complexity as like 0, 1, like Boolean circuits, and you could represent that as so it's known as sum of squares polynomial optimization problem, and then you can essentially represent the circuit as an equivalent algebraic system, and then talk about solutions of the algebraic system to see if it satisfies the constraints posed by the circuit.
Perfect. 3 for 3. How does the theory of optimal transport provide a rigorous mathematical foundation for generative adversarial networks?
Generative adversarial networks are essentially solving a zero-sum game between like two players. Like one is a generator adversary. I think it depends on the formulation, like the exact mathematical formulation. There could be a way to like relate those things, but I see one as a game theory concept and another as more of a stochastic optimal control concept.
4 for 4. Okay, for the final one, do you want to try the hardest astro or hardest computer science one?
Computer science.
Okay. How do interactive proof systems, probabilistically checkable proofs, and the PCP theorem connect to the hardness of approximation, and what does this imply about the limits of efficient algorithms for optimization problems?
So when you talk about limits of optimization problems, right, you define an entire problem class. So you're not giving guarantees for one specific instance, you're giving guarantees for like an entire class of problems. You can translate one class of problems into the other one, which again through a series of mathematical conversions you can change notation into you can come up with an equivalent mathematical system, and then you can make some comments on how the system performance looks like. That's the best I can say.
Yeah, good job. 5 for 5. And what do you want to get into now that you're graduating?
I am looking for industry roles, maybe more startup kind of roles.
Any advice you'd give to anyone going into a PhD?
Well, initially if you had asked me 4-5 years ago, I would say have strong reasons to join the program, but then the reasons change over time also. Yeah, I would just say be curious, be passionate, be a little bit of rebellious to go against the existing ideas also. Be a scientist.
Thanks so much for your time. You killed it, bro. Have a good one.